Hello everyone, welcome to this interesting video where we are going to dive in flipping bit. Flipping bit is a program where we receive as input an integer and we are supposed to convert that integer into the binary version and flipping all the bits in the binary version of the integer to have another binary value, and once having the binary value, now we should give the integer value of that binary value. That means if we receive 1001, which is here, we should have the 32-bit version of this. That means complete with leading 0. And after this, we should flip all of the values into the opposite. After flipping, we should now convert the flip value into integer. This is what this program is about. So now to solve this, I'm going to share with you two approaches. The first one is actually the straightforward approach, like loop, trying to convert and using the power of each of the elements to find exactly what is the integer value of the flip version. And the second one is going to be something more straightforward. So I really advise you to stay to the end of the video to enjoy what will that approach look like. Let us dive into the first approach. So our first approach will be based on like reconstructing the binary version of the integer. What does that mean? That means, let's say I'm having this value 9. 9 is equal to 2 power of 3 plus 2 power of 0. How do I organize to have something like this? So I'm going to say, honestly, I'm going to look from 32 to 0. But in this example, just so we understand better, I'm going to start with something easy. You're going to say this 9 is actually, let's say I'm at position, I'm going to start with 32, like 31, like I said, moving until when I find myself with an element which is actually smaller than my value, I remove that element and continue with the rest. What does that mean? That means I'm moving from 31 to 0. I will start. Is 2 power of 31 actually less than 9? No. I'll move until 3. When I will be at 3, I will see that 2 power of 3 is actually less than 9. Okay. If 2 power of 3 is less than 9, so what I will say is that I will keep the 3. Actually, like in the normal process, you keep the 3. That means the 3 is a 1. And then you move on. And what will be the actual value? The remaining value will be 2 power of 3, which is 8, minus 9, which is 1. So actually your rest is 1. Your rest is 1. Now you move to 2 power of 2. Is 2 power of 2 greater than 1? No. So 2 power of 2, you don't use it, so it's actually 0. Is 2 power of 1 greater or equal to 1? No. Because 2 power of 1 is 2, so you don't use it. At 1, you have also a 0 here. Is 2 power of 0 greater or equal to 1? Yes. So at 0 here, you have a value which is, so you keep it here, and then the rest is actually 0, and this is where you are going to stop. So at the end of the day, you have 0, 1, 0, 0, 1. So now to avoid doing this, and after relooping and found how to flip it, while performing this, you are just going to focus on 0. Why? Because you know all those 0 are going to be converted into 1 in the flip version, and those values you just need to power them. You see, because at the end of the day, to construct like the integer value of this, you just need to make 0 power of 2 power of 0, 2 power of 0 times 0 plus 2 power of 1 times 1. You see, so you move from the left to the right and you just ignore the 0. So you just need to make this one exist. So 2 power of 1, this one exists, 2 power of 2, you skip the 3, 2 power of 4, and so on and so on. So the interesting thing is that when converting this, just ignore the 1 and care about the 0. So what will it look like in the code? So in the code, I'm moving from 31 till 0. When I'm moving from 31 to 0, I will say if n is actually greater or equal to the power at that position, what I was saying here. So if you're greater or equal to the at that position, that means you are a 1. So if you are a 1, I'm just removing you from the initial value to have another rest, and I do nothing. I do nothing because I know the 1 is going to be flipping 0, and I don't need to care about that. But otherwise, it's a value I need to care about. Otherwise, I'll just directly power the element at that position with its position 2 power of this, because I know that it is a 0, and that 0 is going to be flipping to a 1. And by doing so, at the end of the day, this result is going to be what I need. So let me just submit, and you will see something interesting. It is working. Now, our second approach is something really straightforward, that is just an observation. I want to flip this into this, for instance. That means I want to change the 1 into 0, the 0 into 1, and so on. I will start thinking. I want to change the 0 into 1, and I want to change the 1 into 0. Is there not an operator that will help me to flip 0 into 1 and 1 into 0? Yes, there's one. Which one? The OR operator on 1. Because if I have 1, 1 here, and I have an OR here, 1 or 0 is actually 1. 1 or 1 is actually 0. That means if I have a 32-bit, what does that mean? If I have a 32-bit 1, 1, 1, 1, 1 to the end, and I apply the XOR to this guy, I'm going to have the flip version automatically. So the first thing I need to do is just go on any binary element online, type 32.1 and find the integer value of it, copy it, come back to my code, and just instead of having all this loop, I'll just directly return this value XOR n. It's actually the XOR of 111, and this, which is the flip value, and I just return it. Let us submit and see what it gives. It is working perfectly. So those are my two approaches of solving this. Honestly, I enjoy both of them. The first one is more educational, so you understand how to loop, you understand how to power element. The logic is interesting. The second one is also interesting because you learn how to use OR operator, which is actually really nice when it comes to bit manipulation. And yeah, I definitely enjoy going through those two approaches. I hope you too. Feel free to give me a comment. I'll be really happy to interact with you regarding this. See you on the next video. Ciao.